Hello, so I finished 3D printing and assembling the prototype of Kamov KA-50 Undercarriage, which I designed in SolidWorks. So this has been 3D printed on my new Bambulab H2D in Bambulab glass fiber enhanced ABS, so the parts are quite rigid and strong. Yeah, of course here we got a spring-loaded suspension, so this provides quite a lot of resistance. And of course the parts were 3D printed in an orientation to optimize the strength. So here we can see a bit of marking. So this is from the breakaway support material. This can be easily cleaned later on by dissolving in lemonade. So I'm just waiting for the material, for the liquid to arrive. Right, so let's have a look. Nice. I do love when things work. And now retract. And there is very little slack here, so I might correct the orientations, tolerances here a bit to even make it more rigid, half millimeter here, half millimeter there. Now, quite an important thing about Kamov, why I had to do a custom design, not only to make it look scale, but to actually make it function properly, right? So it will be installed at an angle when it comes to the fuselage orientation, and the reason for that is when the fuselage curves, so it's quite goes narrow to the tail, and when the undercarriage retracts or detracts, it goes into the fuselage to blend nicely in. So this require, when modeling, is required finding a specific angle for, let's say, the axis, specific axis for the retraction, and then building the mechanism around that. Now, yeah, so you see now when it retracts, it will face forward in the direction of the fuselage. And again, another custom thing is, which is quite non-standard and required custom design, the retraction, it goes down to 57 degrees down. So standard retracts from planes that are generally around 90 degrees. This goes down only by 57 degrees. Oh, yeah. So next steps will be 3D printing the second pair, 3D printing the segment of the fuselage where this is assembled, this is attached to verify everything is okay, and then continue with work on the fuselage, building the fuselage, and eventually the load test to verify whether the parts are strong enough. So there will be, of course, another one on the other side and the front landing gear. So those three will take a load of around 6 kilograms, so around 2 kilograms each. And it will be a question whether the strength of the 3D printed parts is sufficient or whether they need to be CNC machined. I got a feeling that, yeah, I will need to CNC machine definitely the assembly. But when that happens, I will have to modify the parts to simplify the milling process to make it cost efficient. But that's the beauty of 3D printing. You can prototype and you can iterate on the prototypes quite fast before committing to a expensive process that is CNC milling. Perfect. I do love when things work and they come together.